Hey everyone, Adam here with Old Santee Canal Park's education team. You're probably wondering why I'm standing in the dark right now. The reason I'm standing in the dark right now is because we are going to be talking about space. Now space, the best way to see space is if you walk out into your yard and look up at night. So go out in your yard and look up and see what you can see after this class. So we are going to talk about everything that has to do with space. We're going to start off close and then work our way out. Now, space starts only about 60 miles above Earth. That's when space officially starts. With that being said, the next closest object to us in space is the moon. And the moon is 269,000 miles away, roughly. So it's still pretty far away, but it is the closest object to us in space. So that's what we're going to talk about first. All right, so the moon is fascinating. Now, the moon is just a giant rock. It's made up of mostly iron, but there's some really cool features about the moon. So first you'll notice that the moon has dark spots. So you can see the dark spots right in there. And what those are is when the moon was young, it had volcanoes on it. Those volcanoes would erupt and spew magma and lava all over the moon's surface. Well, eventually that lava and magma cooled down and formed these lava flows. And that's what those dark spots are. They're ancient lava flows called Mars, M-A-R-E-S. Okay. You'll also notice that the moon has a bunch of chickenpox marks on it. It's got a bunch of little craters on its surface. The reason it has little craters on its surface is because the moon has no atmosphere. So what that means is there's no wind, there's no rain, there's nothing to wash away the surface of the moon. So as a result, things on the moon will stay on the moon for hundreds of thousands of years. So when Neil Armstrong, right? One small step for man, one giant leap for mankind. Those footsteps will be on the moon for hundreds of thousands of years. Now, the moon is very, very important to the Earth because of its size. Now, I shrunk the Earth down, so it's in my hand. I've got the whole world in my hand, okay? And then I've got my moon here. So this is exact replica sizes of each. So the moon is about 1/8 the size of Earth. Now, it's about 6 inches away. It's supposed to be 6 inches away. So that's what it looks like. Now, it being 1/8 the size of Earth is important. The reason it's important is because it controls things on Earth. Does anybody know what the moon controls on Earth? It's the tides, right? The moon controls the tides. So every 6 hours as the moon circles around the Earth, it pulls water towards it, okay? So that is why, we have the tides, is because of the moon. It also does the same thing with our atmosphere, but you can't see it doing it with the atmosphere. Now, I have a question for you. Does the moon remain the same or does it change every night? So the answer is a trick question, okay? It stays the same, but it does change. So it stays the same because if you've ever looked up at the moon, we only ever see one side of the moon. The reason being is there's aliens on the other side of the moon and we don't want to see those. No, that's not true. The reason we only ever see one side of the moon is called tidal locking. So what I want with this diagram, the left-hand moon, watch the dark spots. As the moon revolves around the Earth, the dark spots are always facing the Earth. Now, the right-hand moon, if you follow the dark spots, it faces away from the Earth at some point. So the moon on the left is tidally locked like our moon, while the moon on the right is not tidally locked. So we would see all sides of the moon if that was the case, but it's not. The reason the moon is tidally locked is because there's two main forces at work in the universe. The main force, everybody knows, it's gravity. Throw something up, comes right back down, right? Well, the other force is called centrifugal force. An object in motion wants to stay in motion. So, has anyone ridden the ride? It's called the Gravitron at the fair. It spins you really fast and it sticks you against the walls and you can't move. That is not gravity. It's named wrong. It's centrifugal force. That's what's sticking you to the walls. So one force wants to pull you away while the other force wants to pull you in. Well, the moon being tidally locked, it means those forces are in balance. So that means those forces being in balance, we only ever see one side of the moon. And that is why it is tidally locked and we only ever see one side of the moon. That being said, the moon does change, right? And it doesn't look the same every night. So the lunar cycle, it's called, is the changing of the moon. So every 28 days, the moon goes through this lunar cycle. So it's called the phases of the moon. Now, the moon doesn't produce its own light. It is just a giant mirror that shines the light that the sun produces back to us. So as the moon revolves around the earth, the sun hits the moon at different angles, resulting in different shapes. Now, the way you remember this, there's a movie. It's called The Karate Kid. It's not with Jaden Smith, all right? It's the original Karate Kid. And there's a character in it called Mr. Miyagi. And Mr. Miyagi has a famous line called wax on, wax off. And that's how we're going to remember this, okay? So as the moon gets bigger, it's waxing on. As the moon gets smaller, it's waning off. So wax on, wane off. Wax on, wane off. All right? So the cycle starts with a new moon, with the sunlight hitting the back side of the moon. The next is waxing crescent. So think of like Pillsbury Doughboy, crescent rolls. Then first quarter, because it's 1/4 of the way through. Waxing gibbous, that's just hard to remember. Then full moon, then we're waning off, right? So we have waxing on, waning off. So waning gibbous, third quarter, waning crescent, back to new moon. And that is the lunar cycle, or the phases of the moon. So that's how the moon stays the same and it changes. So let's change gears and go into something other than the moon now. So we've got to go to our next closest objects, which are the planets, right? Does anybody know the planets in order? It's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Now, some of you may have said Pluto, but Pluto is no longer a planet. So here's a nice picture of our solar system. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Those are the planets, right? So Pluto is actually a dwarf planet, and now there is 5 dwarf planets. So this is an older picture, but poor Pluto is no longer a planet. So does anyone know what the planets are named after? They are named after Roman gods, except one. Does anybody know which planet that is? It's Earth. Earth is actually named after dirt. We get a really cool name. All right, so dirt. Everybody else gets Roman gods. Now, the first 4 planets are what we call terrestrial planets because they have some sort of land. So Mercury, Venus, Earth, and Mars. Those are our terrestrial planets. The other 4 planets, Jupiter, Saturn, Neptune, Uranus, and Neptune, they are what we call Jovian planets or gas giant planets. How you remember that? It's really easy. terrestrial, land, gas giants, right? Jovial. Think of jovial, happy. Laughing gas, okay? Laughing gas makes you happy, makes you jovial, Jovian, okay? The easy way to remember it. Jovian, terrestrial. So those are your planets. Now, when you see a picture like this, you always think how nicely spaced our solar system is. That is not the case, all right? I'm going to get my planets out. All right, so we are about to misfrizzle this thing and become planets. Now, what I want you to do, if you can find a really open area where you can see for a long ways, I want you to find one object in that area. Let it be a tree, let it be a telephone post, okay? That's gonna be your sun. So this is, I shrunk the sun down so that way I could hold it in my hand. Now, what you're going to do is you're going to become planets. And what I want you to do, I'm going to tell you which planet you're going to become. So the first planet, what I want you to do is I want you to become Mercury. Now, with the picture, they all look semi-equal. Now, you're not going to be able to see this because it's super, super small. But you see that tiny little dot right there? That's the actual size of Mercury compared to the sun. So what I want you to do, from that telephone post or that tree, take 10 steps. So take 10 steps. You're now Mercury. So that's how far Mercury is away from the sun. Now you're going to become Venus. And Venus, it's a little bit bigger. See the little dot right there? So there's Venus, all right? In order to become Venus, you're going to take 9 more steps from where you're at. So 9 more steps. So now from where you are to the tree is how far Venus is away. Then we have Earth. So Earth is a little bit bigger. You can see it, all right? What I want you to do now to become Earth is you're going to take 10 more steps from where you're at. That's Earth. Then Mars, okay? Mars. Mars is itty bitty again. So let me see. It's right. Can you kind of see it? You can't really see it. It's that little dot right there, okay? So Mars is itty bitty again. So those are our 4 terrestrial planets. So what I want you to do to become Mars is I want you to take 10 more steps to become Mars. So 10 steps from where you were for Earth, you're now Mars. So look back at your tree and see how far away that is. You're relatively close to that tree. Now, here comes Jupiter. Remember, Jupiter is a gas giant. It's a Jovian planet. The 4 terrestrial planets, you'll notice, are very close to your tree. But with the gas giant planets, here's Jupiter. It is about the size of a gumball compared to our sun. All right, here's our gumball planet. Now, for Jupiter, what I want you to do is I want you to take 100 steps from where you are at, if you can. If you can't, just know it's 100 more steps from where you're at. So the point of this is the Jovian planets are much larger than the terrestrial planets. They're also very spread out compared to the terrestrial planets. The terrestrial planets are very close together and very small, like grains of sand. So the pictures you see online, not right? Because they have the sizes wrong and they have the distances wrong. But it's still a pretty good accurate representation. It's an accurate representation of our solar system because if the pictures actually showed how big and how small and how far apart the planets were, you would never be able to see them on a picture. So that's why I said it's an accurate representation, so we can see all the planets. Now what we're gonna do, we're gonna turn our attention to the center of our solar system, the giant ball of fire called our sun. So in order to talk about the sun, we are going to learn a song. And this song, has anyone seen Finding Nemo? Well, at the very end of Finding Nemo, Nemo is going to school. Mr. Ray is the school bus driver. And so Mr. Ray, as he's swimming off, taking Nemo to school, starts singing the song. It's called the Sun Song. And we are going to sing it now. So everybody repeat after me. The sun is a mass of incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of millions of degrees. So everybody repeat after me. We're going to go a little faster. The sun is a mass of incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of millions of degrees. So hopefully you got it. So that is the Sun Song. And it's exactly what the sun is. It is a giant ball of gas that is constantly turning into another gas that produces energy in lots of it at a temperatures of millions of degrees. It is responsible for providing energy and heat for our entire solar system. So that is our sun. Now all suns are stars, so all stars are suns. Now they come in all different shapes and sizes. So the first type of star we're going to talk about is called a red dwarf. And what I mean by a red dwarf is that it is smaller and it doesn't burn as hot as other stars. So what that does is it allows it to live for a very long time. As a result, it is the most numerous star in the universe. With that being said, there are more stars in the universe than grains of sand on every beach. So just imagine how many grains of sand are on beaches on the earth. There's more stars than that. That's a law of stars. So the most numerous is going to be our red dwarf. Our star is called a yellow dwarf. It is like the Goldilocks of stars. It's not too hot, not too cold, not too big, not too small, just right. Then, as our star begins to age and grow bigger, what happens is that it gets hotter and hotter, and eventually will turn into one of these. This is called a blue giant. This is the hottest burning star. So it is going through its hydrogen very, very, very fast. So what that means is dying faster. So as it burns faster, it's dying faster. So as a result, it'll eventually run out of hydrogen and turn into one of these guys. This is a red giant. So this is one of the coldest stars. And what I mean by coldest is still hundreds of millions of degrees. It's still very, very hot. But the reason it's the coldest is now it's starting to burn helium instead of hydrogen. Helium doesn't burn as well as hydrogen, so it's not very hot. And just to give you an idea of how big this star is, you remember how far you were from that tree? Well, when you were Jupiter? Well, this star, if our star became a red giant, it will swallow Jupiter. So this is a huge, huge star. And this star is going to die. It's very short-lived. And there's two ways a star dies. Does anybody know? One of them is called a supernova, which means it collapses in on itself and explodes and sends stardust all over the place. The other one, okay, is the sun collapses in on itself and then turns into a black hole. That is the two ways a sun dies. So we just talked about some of the few different stars there are, but there's lots and lots of different stars, right? We talked about there's more stars than grains of sand on every beach. So what happened long time ago, people didn't have computers, they didn't have phones, they didn't have Instagrams and Facebooks and TikTok accounts and all that crazy stuff. Most people didn't even have books. Okay, so what that means is they only had stories, and the stories were to teach you how to act and behave, and that's where constellations came in. So what constellations are is they're stories, and they're supposed to teach you how to act and how to behave. Now there's 88 different constellations. 48 of those are ancient constellations. They're first documented by a guy named Ptolemy. So Ptolemy lived in ancient Greece, Rome, and Egypt. So he compiled all these different stories into one book. So that's why he's credited with founding the constellations. But they existed long before Ptolemy ever wrote them down. Now, the reason why he's only got 48 of the 88 is because he lived in that very small area. Now, the earth, as we know it, is much larger than Greece and Rome and Egypt. There's North America, there's the Antarctica. So as a result, in Australia, as a result, all these different areas becoming founded, that means there was more night sky. And so we had to fill in the rest of those constellations. So fill in the rest of that night sky with constellations. So that's where the 40 new constellations came in. So when you go outside and you look up at night, there's some constellations that I want you to know. So we're going to look at some very specific constellations right now. The first constellation probably everybody knows because it's the easiest constellation to find. And that's the Big Dipper or the Little Dipper. So the Big Dipper is the easiest because it is the largest. It's called the Big Bear or Ursa Major. Now, if you need help finding the Little Dipper, you just follow the front edge of the Big Dipper to the tail of the Little Dipper, specifically Polaris. Now, Polaris is a really cool star. Now, has anyone seen the movie Moana? Well, Moana gets lost in the ocean. When she's lost in the ocean, she has to find her way. And she does it using the tides and the current. Well, if you are ever lost, can navigate by the stars. And the star you're going to use is Polaris. It's called the North Star because it always points north. So if you find that star and you face it and you stick your arms out and go "we," your left arm will be west, your right arm will be east, and behind you will be south. So now you have a compass to find your way, just like Moana. The next star constellation actually runs itself right in between Ursa Major and Ursa Minor, and it's called Draco the Dragon. Now, Draco the Dragon has a cool story because it's part of Hercules. Now, has anyone heard of Hercules? You've probably seen the movie. The story of Hercules has a lot of constellations tied to it. The reason being is because Hercules had a curse put on him. A curse that could only be lifted by doing 12 impossible tasks. You've probably heard of some of these constellations that are tied to the Hercules story or saga. One of them, we talked about, Draco the Dragon. He had to get a golden apple from a secret garden protected by Draco. He eventually ended up defeating Draco and getting that golden apple. He also had to defeat Leo the lion, Taurus the bull, Cancer the crab, the Hydra. The Hydra was the evil monster that if you cut one head off, two would grow back. So there is lots and lots of constellations tied to the Hercules story. And the reason why is because it's very important for people to know the Hercules story. Now, Hercules, the reason why you should know the Hercules story is because it teaches a great life lesson. The lesson is, no matter what you face, no matter what impossible task is in front of you, you can overcome it, you can defeat it, and you can come out better for it. That's why the story of Hercules is so important. That's why there's so many constellations tied to Hercules, is because everybody has problems. Everybody has impossible tasks in front of them that they have to overcome. And you can do it. So that's why Hercules is so important. The next easy constellation to find is Orion, or the Great Hunter. And the reason it's easy is because of Orion's belt. It's the group of stars right around the waist of Orion. It's called a nebula. And the reason it's so bright is because a star supernovaed and exploded and sent stardust all over. And what's going on is that stardust is now creating new stars in that nebula. So Orion's belt has a cluster of stars that are very bright. That's why it's easy to find. Orion is called the Great Hunter. He's got a bow, you can see, and he's got two dogs, Canis Major and Canis Minor. You can't see Canis Minor right now. But Canis Major is actually the reason why it's called the dog days of summer. The dog days of summer is the hottest days of summer. And the reason it's called that is because it's the highest in the night sky during the hottest months, July and August. So they thought the dog, or Canis Major, was responsible for the temperature on Earth. So now back to Orion. The reason why Orion is in the night sky is because he bragged a lot. Nobody likes people who brag. So what happened, Orion would tell everybody that he was the greatest hunter to ever live. Didn't like that very much. People didn't like that. So what happened was a giant scorpion was sent down called Scorpio, and a great battle ensued. And Orion and Scorpio fought and fought and fought. Eventually, Scorpio stung Orion, and Orion died. Well, Scorpio, suffering such bad wounds from the battle, died as well. What that resulted in both being put in the night sky to memorialize that great battle. Well, Orion had to be punished. Well, just underneath Orion's feet, right in there, is a constellation called Lepus, the rabbit. So everybody's probably seen Tom and Jerry or the Roadrunner and the Coyote. It's the same premise, okay? Same story. Orion is constantly chasing after the rabbit, which is just underneath his feet, but he can never catch it for eternity, just like Tom and Jerry or the Roadrunner and Coyote. So I just covered a few of the constellations in the night sky. There are far more that you can go out and learn on your own and find. It's fun. It's exciting. Now, the night sky does change each night, so you'll have to look for certain characteristics. With that being said, space, there's so much more to learn about space. It is amazing. It's infinite, all right? So just a few facts I want to talk about before I leave. So the facts, I call them Snapple facts because there's a fact under each Snapple lid. So the Earth is 140 million miles from Mars. A light year is 5.88 trillion miles. The width of the Milky Way is 100,000 light years. Andromeda is the next closest spiral galaxy at 2 million light years and is set to collide with our galaxy in 5 billion years, creating a super galaxy. The hottest planet is Venus at 450 degrees Fahrenheit. The reason it's not Mercury is because Venus has an atmosphere. So that atmosphere traps hot air and gases like a greenhouse does and makes it super hot. There are 1,800 confirmed exoplanets with 3,000 awaiting confirmation. So lots of planets for aliens, okay? The fastest winds are on Neptune with 1,600 miles an hour. Space is silent. The reason it's silent is because there's no air in space. It's a vacuum. So, but how do we say, Houston, there's a problem? The reason Houston, there's a problem and still hear it is because of radio waves. Radio waves are energy waves that are sent, and that's what can pass through space. Now, the sun is like 1.8 billion nuclear warheads exploding every second. So, lots and lots of energy. Now, thanks for joining me on this virtual field trip. I hope you learned something. If you have any questions, feel free to give me a call at 1-843-899-5200 or come out and visit the park. We're located at 900 Stony Landing Road, Moncks Corner, South Carolina. I hope to see you soon. Take care. Bye.